Okay, so look at this one container. So wait, I can draw one more. It's not like perfectly visible to you guys, so that's why this one is better. Okay, so I'm drawing this one, and you can easily see the particles from here. And you know that every molecule in any type of liquid attract each other. Why this so? As we have studied in our video that we are having two types of attraction: the attraction between molecules to molecules called cohesive force. So this is a cohesive force which is attracting from molecule to molecule. Consider this one molecule, which is I am giving the name as B molecule. So here you can see that there means from every direction the net force of this molecule is equals to 0. What is the net force? Net force is the means the total force acting on a particle or any object. So here for example we are having force from this angle and this angle, so it has been cancelling to each other, and this angle and at the every angle, and the force is cancelling to each other. Okay, so like that, if we are talking about this one particles which are like at the upper side of liquid. For example, here we can see that this particle is having attraction with this one. But what about the opposite attraction of this one force? For example, this one, where is the opposite force? So it means because of not having any opposite force towards this one force, so there is some like pulling to be start, and that pulling is on the downward side. Why that pulling is on the downward side? The uh, reason is that our particle is moving downside, and there is no any force which can against which can act against of it itself. So that is why the particles of any liquid, for consider this is the H2O. Okay, so that's why the particles of water will be pulling towards downward. So uh, it is like because of there are many factors of surface tension, but we can say that there are total three factors which we'll be going to study today. uh, for example, the one is temperature, and the other one is the force of attraction. Force of attraction. And one thing also matter, that what type of force is present between molecules to molecules. Okay, so now suppose this one is a container, and here we are having net force equals to 0, but here the net force is like not equals to 0. Here net force is not equals to 0 means there is some force which is present. Okay, which is like resulting the water molecule to pull the downward, and cause of that water molecule possess a spherical shape when we, like for example this is a tap. Okay, and this one is a tap. Okay, when we drop liquid from here, then it is like this. Okay, it is having a like improper shape, but when it comes here, then it change itself into a spherical shape. Why into a spherical shape? Because there is a surface tension which is present, and surface tension cause the water molecule to be spherical. And because why surface tension uh, result the water molecule to be spherical? The reason is that there is a force which is acting on the particles, and that force is like pulling downward to the molecule. So when the molecule like gets separate from tap, then it converts into an spherical shape. Okay, so now let's go through this one factors. So how temperature affects the surface tension? So temperature is basically inversely proportional to surface tension. How it is inversely proportional? For example, consider an ice here. Okay, ice. And consider warm water here. Warm water. So according to you guys, which one will be like more harder? So the ice will be more harder as compared to water, and the reason behind it is that the molecules are attracted this thing. The molecules of ice are like this. So it's like in surface tension, the molecules are like more attracting towards downward because of the decrease in temperature. And if you look at a liquid molecule which is like a bit warm, so here we are having a more kinetic energy. Okay, here we are having a more kinetic energy. So that kinetic energy also kinetic energy is also a factor in surface tension. So cause of that, there is a low surface tension. Why there is a low surface tension? Because there is not that much the pulling of particle as we are having as we are having in ice. The reason behind it that the temp when we are increasing the temperature, then there is one more thing also increasing, that is in the form of kinetic energy. So when kinetic energy increases, so it means when means it, here two things are acting on a single substance, and here we are having less kinetic energy but more surface tension, more pulling downward of particles. Here we are having pulling downward of particles, but because of kinetic energy it is like imbalancing the both things, so that is why. So here we are having less surface tension, and in ice we are having greater. Okay, greater surface tension. Okay, so let's go through this one. Force of attraction, I can easily give you the example. For example, like we are having a particle which is uh, being which is cohesive to each other. For example, like here we are having an spherical. How it is maintaining to its position? Because of a force which is called cohesive force. This action is known as surface tension, but the force behind it is a cohesive force. For example, this one, this one whole process is called surface tension. Okay, but that force between molecules to molecules is called uh, cohesive force. So means the more the cohesive force will be, the more the surface tension will be. For example, here we are having force of attraction, more force of attraction in water molecule as compared to in honey molecule. Okay, so honey molecule is like quite more spreaded than the water molecule. Water molecule is like spherical. Okay, honey. So just suppose this, I don't know that the honey molecule is like this or not. Just suppose this, that honey molecule is like this. Okay, so for example, H2O is a spherical and honey is a quite more spreaded than H2O. The reason behind it that in H2O we are having the stronger molecule, stronger force of attraction as compared to honey, and that stronger force of attraction cause the molecules to be more spherical shape, and that spherical shape made this molecule as a more surface tensionized. Okay, so now let's look at the second topic, which is capillary action. Capillary action. Okay, so here we are having like meniscus form in like tube-like structure, that is like having two types of shape: concave meniscus and convex meniscus. Concave meniscus. Okay, so in concave meniscus we are having, like for example, this is a glass, and here we are having like means as you guys know that water, oh sorry, mercury make a shape like this. Why it is like this, I will tell you today, and why a water molecule make a shape like this. Because here we are having the more cohesive force as compared to the adhesive force. The concave meniscus means that the more the less attraction of liquid particles towards the glass, and convex meniscus is like the more attraction of liquid particles towards the glass. Okay, and this is because of like force of attraction. No, we can easily say that like this is because of the arrangement of particles. And you guys know that here in glass we also use silicone, and silicone is like less electronegative than hydrogen, less polar than hydrogen. Okay, for example, consider this Si molecule. So when we are having like H2O in a beaker, so or oxygen particle will try to gain the electron of oxygen or silicones. So then it will try to attract the silicon molecule. So because of that, this H2O is like attracted toward the uh, and this one glass, and here mercury do not try to attract the electron. Instead of attracting it, like repels itself towards the glass, and cause of that it makes a dome shape, and that dome shape is known as concave meniscus. Thanks for watching this video.